So, where were we? The critical micelle concentration. So, in case of critical micelle concentration, the surface active agents preferentially get absorbed at air-water interface. As the concentration of surfactants increases, the molecules get accumulated progressively at the interface. In this process, at one particular concentration, the interface gets saturated. While the bulk phase is saturated with monomers, the formation of micelle so spontaneous that it is difficult to differentiate the concentrations related to saturated phase and micelle phase. In the bulk of the solution, both monomers and micelle are in dynamic equilibrium. This concentration is called as critical micelle concentration. Beyond the critical micelle concentration, any further addition of surface active agents enhances the formation of micelles only. This process is so much spontaneous, therefore the therefore the free energy of the system is reduced. So preparation of association colloids is easy for this reason, only for critical micelle concentration or only from the micelle formation. Some examples of surface active agents there are anionic type, cationic type, non-ionic type, ampholytic type. Anionic type is SLS. Surfactants, the examples of surfactants I have already discussed in Unit 3. Anionic type is SLS. Cationic type is cetyl trimethyl ammonium bromide or cetrimide. Non-ionic type polyoxyethylene lauryl ether. Now ampholytic dimethyl dodecyl ammonopropane sulfonate. So see here micelles are forming. These alls are polar head or hydrophilic head and these are hydrophobic tail. Surfactants are arranged themselves on the water surface like monolayer of the molecules. See, here layer is forming monolayer of the molecules and inside it as micelle and membranes tied by their hydrophobic tail. As a micelle and membranes tied by their hydrophobic tail, as the cohesion of these molecules is interior to that of molecules of water, the surface tension of water is lower. The layer of soapy water is a layer of soapy water. The molecules of surfactants arrange themselves with the head in the water, the tail the outside. See, this is the micellar forms. This is forming a vesicle. Here, here the polar part, the polar head is a non-polar tail. Sorry, the non-polar tail forming the micelle. This is actually a bilayer. This is a single layer. It's a hydrophilic head or polar head, the hydrophobic tail. It's a forming micelle. So all I understand that what is an association colloids. As with lyophilic salts, formation of association colloids is spontaneous, provided that the concentration of the amphiphile in the solution exceeds the CMC or critical micelle concentration. I have already told the examples of amphiphiles or association colloids. Anionic, cationic, non-ionic, and ampholytic or zwitterionic. Anionic is SLS, sodium lauryl sulfate. Cationic is acetyl triethyl ammonium bromide. Non-ionic is polyoxyethylene lauryl ether, and zwitterionic is dimethyl dodecyl ammonopropane sulfonate. So this is a brief comparison of properties of colloidal salts. The influence of methylations on some physical properties of surfactant or surfactant solutions in which the properties such as conductivity, density, and detergency also exhibits changes, though the micelle assume spherical shape near critical micelle concentration, and in micelle, tails face towards in center here. The tails face toward in center and create hydrophobic environment. The polar heads tends to associate with water molecules and to form the surface of the micelle. When a nonpolar dispersion medium is used, the opposite behavior is observed. Polar heads face inwards, creating an aqueous pockets. This is an aqueous pockets, and polar heads are inward. Aqueous pockets is forming here. The hydrocarbon portion associated with the nonpolar medium. At higher concentration, laminar micelle are also formed in which exist in equilibrium with spherical forms. So, micelles are considered as the molecular association. Here, it is important to recognize that micellization is merely a pattern of association. In case of micellization, defined critical micelle concentration value is possible. On the other hand, self-association is a continuous process. Therefore, there is no equivalent to critical micelle concentration, and there is a wide range of aggregation size in solution. For example, purine and pyrimidine base of nucleotides undergo self-association in which a stacking process is observed. Next important thing in case of association colloids um, is Kraft point, which is denoted by Kt. Kraft point, the solubility of surface active agents depends on the temperature of the system, but adequate concentration of surface active agents is required to form micelle. The relationship is stated by Kraft point. So Kraft point is defined as the temperature at which the solubility of the surfactant is equal to the critical micelle concentration.